Okay, so what we're going to be looking at here is that we're going to be looking at radicals, and this is kind of an example of how these videos are going to be working. So this is just going to be how to simplify radicals, and I'm just going to step through. Okay, so the first thing is what radicals are. So what radicals are your square roots. So if you're given something like the square root of 64, hopefully you remember these from when earlier classes. So the square root of 64 is 8. Okay. And the square root of 121 is 11. Okay, and to find these is that you got to find what number when you square it. 8 squared gets you 64. 11 squared gets you 121. So then you take the square root of it, which means you're trying to find what number squared gets you the number underneath the radical. And so the ones up to at least 12, hopefully you remember. 1, 4, 9, 16, 25. 36, 49, 64, 81, 100, 121, 144. And then after that, you got 169, 196, 225, etc., etc. So hopefully you know at least the basics so that when you see these, you can go, okay, I got that real quick. Okay. Now, let's say you have something that doesn't. So like 45 does not break down into a nice radical into just two separate numbers. And so what you're going to have to do is you're going to want to prime factor 45. So what two numbers multiplied together get you 45? Well, 5 and 9. Two numbers multiplied together to get you 9 is 3 and 3. So that means your primes are 3 times 3 times 5. So 3 times 3 times 5 gets you 45. Now when you're dealing with square root, what you're looking for is you're looking for your pairs. Okay, pairs come out as 1. So the two 3's come out as only 1 3. Okay. One thing I like to say is that couples go out, singles stay home would be the way to help you remember this. You have to have two together and they come out as 1. And so your answer for this would be 3, the pair 3's that come out, multiplied by the square root of 5, because the 5 has not come out yet. And so there would be your answer would be 3 root 5. That is the simplified version of 45. Okay, so now we look at 180. So the prime factorization of 180, well, you've got 18 and 10 can be broken down, and then you've got 9 and 2, and we've got 2 and 5, and then we have 3 and 3. Well, when we write this one out, we've got 2 times 2 times 3 times 3 times 5. Okay. So now what numbers are the same? Well, we've got a pair of 2's and we've got a pair of 3's. So the 2's come out as 1 and the 3's come out as 1. So now we have 2 times 3 root 5. 2 times 3 is 6, giving you 6 root 5. And as you see, those are the exact same. And that's just a simplified. So when you're simplifying these radicals, you want to break it up into its prime factorization and then take the groups out. Okay. All right, so now let's say we throw in variables. So the coefficient, or the number out front, you're going to do the same thing. So 20 breaks down to 210 and then 25, which means we have root 2 times 2 times 5, or 2 times 2 times 5. The 2's come out, okay, leaving you with 2 root 5. So that is just the 20. Right. So now you look at the 4. Well, x to the 4th is the same as saying x times x times x times x. Now how many pairs can you make of x's? 1, 2. So that means you have x come out and you have another x come out. X times x is x squared. So now you multiply those two to the 2 out front, giving you 2x squared root 5. Okay. So now you do the same thing. Now another way of doing this would be just taking the exponent 4, dividing it by 2. We need 2 pairs, giving you 2. That's going to be the power on the outside of the radical. Any remainder is the power on the inside. Okay. When we get to higher level radicals, you'll be able to see sometimes they stay out and sometimes they stay in. So now let's look at this one. So we've got 18. 18 can be broken up into 9 and 2, which then is 3, 3, which means we have 3 times 3 times 2. The 3's come out, the 2 stays home, which means we're going to have 3 something square root 2 with whatever's left over. So now let's look at the A. Okay, so a's to the third. Well, if we use the rule that we previously stated, we're going to divide those numbers in half. Half of 3 is 1, so we have a to the first, and then we have 1 left over, which means we leave 1 under. Now we go to the b. 4 divided by 2 is 2, means we got b squared. Okay, and since we have nothing left over, nothing goes under the radical. The last one, c to the 12th. 12 divided by 2 is 6, which means we have c 6. So our answer, so the simplified version of this one would be 3ab squared c6 times the square root of 2a. Okay. So again, it's just breaking it down slowly, slowly, slowly. So now let's say we have larger. So now we've got this little 3 and we've got a 5 out front of these two. And the only thing that changes here is that instead of wanting pairs like we wanted previously, now we want whatever that number is out front. So if we have a 3, we want to get a 3 of a kind. And then the second one, we want to get 5 out. So let's look at 27. Well, 27 can be broken up into 3, 9, and then 3, 3. So that means we've got the square root of 3 times 3 times 3. There's your 3 of a kind, so they all come out. Now let's look at the 6. So now we're going to take 6, divide it by 3. The power divided by the number out front gets us 2. So we're going to have, our answer is 3, the number came out, times x squared. And that is the simplified version of the cube root of that one. So the next one we want 5. So since as we see here we've got no coefficients, it's only variables, so we're going to divide each of these individually by 5. Okay. So 3 divided by 5 gets you remainder 3 with a 0, which means no q comes out, which means they all stay underneath. So it's q3. We had a remainder 3. Now we go to w. 7 divided by 5 is 1. Okay, 1 with a remainder 2. So underneath we have 2, and then we just have that w. E, 5 over 5 is 1, which means we just have an e. Okay, and nothing's underneath, no e is under the radical. Then we go to r, divide that by 5. 12 divided by 5 is 2, remainder 2, which means we have r squared, okay, outside and then inside. And now we go to t, or 8. 8 divided by 5 is 1, with 3 left over. And then y, 21 divided by 5 is 4, remainder 1. So we have y, 4, and then we have just y underneath. And that would be your simplified version of that one to the 5th. Oh, and then you want to make sure you put the 5th root attached to this radical. Okay, just to make sure you specify that it is a 5th root. Okay. All right. So now your iRAT. So what your iRAT is, your individual readiness assurance test. And basically what you're going to do here is that you're going to answer these, all 3 of these, bring them into class, and then in class you're going to do a couple more examples, then you're going to have time to ask questions and everything. So you're going to simplify each of these radicals, and then going to work on more problems in class. Okay? So that's your iRAT.